An ordinary eraser does not simply erase a mark. It physically shears off pencil graphite at a microscopic level. This unassuming tool executes a precise mechanical abrasion, continuously sacrificing itself to make your mistakes disappear. For centuries, people used various crude methods to remove written errors, including breadcrumbs and even wads of wax. These early attempts were often messy, inefficient, and frequently damaged the delicate paper surface itself. The revolutionary invention of rubber erasers fundamentally transformed writing and drawing practices across the globe. Suddenly, artists and scholars gained the freedom to experiment without the fear of permanent, uncorrectable mistakes. This ubiquitous stationary item hides a fascinating interplay of material science and applied mechanical forces. Its simple appearance belies the complex process occurring every time you rub it across a page. Understanding the eraser's operation unveils the hidden engineering marvels present in seemingly mundane objects. This device perfectly exemplifies how basic friction and material properties can combine for powerful utility. It's a testament to the ingenuity behind tools designed for everyday, repetitive, and essential tasks.
We often overlook the subtle mechanics that empower us to refine our work with such effortless precision.
Yet, without this small invention, our creative and learning processes would be significantly more constrained. The eraser stands as a silent monument to the power of mechanical correction and persistent refinement. At its core, an eraser is typically made from rubber or a synthetic plastic polymer like vinyl. These specific materials possess crucial viscoelastic properties, allowing both flexibility and essential firmness during use. When you begin to rub an eraser across a pencil mark, friction immediately starts to build between the surfaces. This friction generates a small amount of heat, causing the eraser material to soften and deform ever so slightly. Pencil graphite, composed of countless layers of carbon atoms, adheres quite weakly to the paper's rough texture. Imagine the eraser's surface as a microscopic landscape filled with countless tiny, adhesive hooks.
As the eraser moves, these minute projections physically grab onto and lift the loose graphite particles from the paper.
The graphite flakes cling to the eraser surface through a combination of van der Waals forces and mechanical interlocking.
But that's not the strangest part. The eraser itself undergoes a continuous, self-sacrificing transformation to function.
Self causes minuscule sacrificing fragments of the eraser transformation to function material to break off systematically. These tiny detached bits then encapsulate the lifted graphite particles, preventing them from redepositing onto the paper. This ingenious self-cleaning mechanism ensures that the eraser surface remains fresh and effective with each subsequent stroke. Without this shedding, the eraser would quickly become saturated with graphite and simply smear existing marks. But how do different eraser types achieve these varied results and specialized functions? Traditional pink erasers often incorporate fine abrasive fillers, such as powdered pumice, a volcanic rock. This added grit provides extra scrubbing power, allowing them to tackle stubborn, deeply embedded pencil marks. The harder pumice particles effectively scrape away the more resistant graphite layers with greater force. Conversely, overall action, specifically vinyl or designed for use on plastic delicate erasers, are papers. Overall action, minimizing the risk of tearing or damaging the surface. Their plasticized surface relies more heavily on adhesive properties, gently lifting graphite rather than aggressively scraping. Kneaded erasers, another distinct type, work by absorption, pulling graphite into their malleable, putty-like structure. These unique erasers are particularly valuable for artists, allowing them to lighten lines without creating dust or residue. But the true mechanical genius lies in how these different materials interact at a molecular level. The choice of eraser material directly influences its mechanical interaction with both graphite and the paper itself. Engineers carefully select polymers and additives to achieve the desired balance of abrasion, adhesion, and durability. This intricate material science ensures the eraser performs its function without causing collateral damage. Writing surface. It proves that even the simplest tools rely on sophisticated material properties and design principles. Every successful erasure is a testament to this remarkable, self-renewing mechanical process. The design ensures maximum efficiency while extending the lifespan of both the tool and the paper. This constant shedding of material is the key to its enduring effectiveness over many uses, and the innovation continues, with new materials offering even greater precision and less residual debris. This remarkable balance of adhesion and controlled abrasion has had immense real-world consequences. The eraser's simple yet effective design permits efficient error correction without damaging underlying paper fibers. Its widespread adoption fundamentally changed practices in art, architecture, education, and professional drafting. Imagine the immense frustration and lost productivity if every minor mistake necessitated starting an entire drawing anew. The eraser enables iterative design, encouraging boundless experimentation and fostering greater creative freedom in all fields.
It empowers individuals to learn from errors, making every creative or academic process more forgiving and dynamic.
This small, humble tool profoundly alters how we interact with, manipulate, and refine written and drawn information. The continuous cycle of material shedding and graphite removal makes complex, multi-stage tasks achievable. Without its mechanical intervention, many detailed plans and elaborate artworks would be far more challenging to complete. It democratizes the creative process, making high-quality results accessible to a wider range of skilled individuals. The eraser stands as a foundational instrument for perfecting designs, refining concepts, and mastering techniques. The everyday eraser showcases ingenious mechanical design, transforming simple friction into sophisticated, self-cleaning error correction. If you found this microscopic marvel fascinating, subscribe for more incredible stories about hidden engineering in common objects. Let me know in the comments what other unassuming devices you'd like us to mechanically dissect next.